All right, so I'll start introducing myself real quickly. My name is Steven. I am an Android engineer at a ticketing company here in New York called SeatGeek. You should check out our app. It's pretty good if you like going to live events. So today I want to talk to everyone about RxJava, and specifically RxJava when being used to talk over the network to APIs. A lot of times, and those APIs are defined using Retrofit. This is a pretty common set of tools that have become essentially industry standard for application development on the Android platform. But we have, as more experienced engineers who have spent a lot of time working with these tools, in my opinion, not done the best job of explaining how to properly use them in the context of building an Android application. I think we have lots of great intro to various topic talks out there, but the one talk that I wanted to give, and hopefully I get at parts of it today, is the intro to using RxJava and Retrofit together in your application to build like an actual experience. So I still find that questions being asked on Stack Overflow and comments and that sort of thing on blog posts are coming from more junior engineers that are making the same mistakes over and over again that we've been telling them for so long to use these tools because they're better. This is better than async task. This is better than loaders. But I don't think that we've done a good job of explaining exactly how to use these tools in a way that's more effective. So this talk kind of is not going to explain RxJava. It's not going to explain Retrofit. It's going to kind of explain how to integrate them into some specific app purposes. So hopefully you're able to kind of follow along. So in a lot of intro to Retrofit talks or a lot of intro to RxJava talks, you'll see a very similar observable setup to this. All right, so here you can see we have an interface definition that we're using for Retrofit. We're using the Retrofit builder to build our Retrofit instance. We're then getting our instance, in this case, our SeatGeek API class. We're going to fetch some events because we want all the events to display for a user. So we've got our observable stream that we're building here. We've got, we're calling into our API to get our upcoming events. We're subscribing on an IO thread so that we're not blocking our main thread. We're observing on the main thread so we get our events back in a way that we can update our user interface. Hopefully you've all seen this sort of example. This is a pretty canonical example of using Retrofit and loading data. And on its surface, this might seem like a sufficient enough introduction. And maybe some more experienced engineers that have more experience with application programming might be able to take an example like this and then apply other patterns to it so that they can actually build an application from it. But I find that a lot of Android engineers are either younger students that are coming directly out of school, or they're coming out of self-taught, or they're self-taught, or they've come out of boot camps, that sort of thing. And so they don't have the full context of how to build applications. And so examples like this aren't particularly useful to them, and they end up shooting themselves in the foot, for lack of a better term. So what doesn't this handle? There's a lot of different things, and I'm sure many of you have complex applications where you have to handle all sorts of different edge cases related to dealing with the network. I listed a few of them here. If you wanted to show a loading indicator, or maybe there was an error in the request and you wanted to retry it, or something that everyone has to deal with is some of the configuration changes and subscription management on the Android platform. Your activities are being restarted constantly. And the example that we just showed doesn't cover any of these topics. And if we're going to say that RxJava is better than async task, then we need to actually solve all of these problems, because these are the problems that applications have that we need to set examples for. So my goal today is to show some patterns to solve specifically these problems, but hopefully they're applicable to other parts of your application and you can kind of reapply them as you see fit. So how can we improve? So we recognize, of course, that there are improvements that we can be made off that first example. So we want to get it production ready, and one of the first things that gets an application production ready is dealing with request failures. Mobile networks are notoriously unreliable, right? So my network requests fail all the time. And one of the biggest things that drew me to RxJava initially was I was excited that there was like explicit error handling as part of the stream. There's an on error here. I know that that's where I can go to handle errors and make things better for my users. and it wasn't optional, right? If I didn't handle an error, my application would crash. I couldn't just like try, catch, ignore, right? My application was going to crash. I mean, I guess I could add on error handling and not do anything there, but hopefully that would get caught in some sort of code review or that sort of thing. Usually just sending code, sending an error message to on error is not enough, though. You have to have strategies for managing error states, and you might have specific concerns regarding these network errors that your application needs to handle. And so let's kind of go into what we're going to do here. So we're going to start by trying to retry requests. So I'd say maybe, I don't know, at least in my application, we're building, a pretty standard, like kind of data feed style application. This is pretty common in apps. So you're 95% of the time, if the request to refresh the data that the user is going to see fails, you're going to show some sort of state that says, I want to let the user retry the request. So right now, in this example, we don't have any error handling, so that's going to be a little bit of a problem. So let's say we want to just automatically retry a request a couple times if it fails, all right? So to a more junior engineer, this might seem like a good solution. I'm creating my observer here, and in on error, I'm handling it. And I check some condition, maybe it's an accumulator that, it counts up a certain number and then stops, and we're just making a request again. So on its surface, this is doing what we're hoping to accomplish, right? This is making retries to the request, but hopefully this is sufficiently frightening to enough of you that you would not put this in your production code, because if this some condition somehow gets out of whack, or in a refactor it gets lost or something like that, all of a sudden you're DDoSing yourself when something goes wrong on your server end. If your server starts throwing 500s and that condition doesn't get met, and all of your applications all at the same time are slamming your server over and over again, you're going to have a lot of angry engineers on your operations team. So when you see patterns like this, I think you see people who are coming from a world of callbacks, people who are coming from like a JavaScript world, or they're coming from maybe like Retrofit 1.0 when it didn't have an RxJava adapter, and they haven't quite moved from the concept of making an observable stream to making an observable stream, and they're still thinking of observers as fancy callbacks. And so this indicates to me that they haven't quite grokked the understanding that a stream is something that you can manipulate. So let's kind of look at some ways that we can manipulate a stream to retry requests. So say we wanted to perform some sort of exponential backoff on our request, right? So we're going to retry it a couple times, but we're not going to slam our server. So what are some ways we can do that? One of the ones that's built right into RxJava is the retry when operator. So the retry when operator can be a little tricky, and it's not necessarily the most intuitive thing to work with. But what you're going to do is you're going to receive in the retry when operator a stream of the errors from the upstream observable. Okay, and that's what I have marked here as attempt. Okay, so that was an attempt that failed. So we get an error. In this example, we're going to retry 3 times, each time getting exponentially longer. Well, not even exponentially. Well, I guess it is exponential. But what we're going to do is we're going to zip with the observable range 1 to 3. So what that will do is we now have an observable that's only going to emit 3 times. It'll emit once for the first error, once for the second error, once for the third error. And then once that zip completes, that observable stream will stop, and then the retry when will stop, and the on error will then finally actually be delivered further down the stream. So this is kind of like a roadblock for errors. Once an error gets here, it enters into this like small little observable world where it gets handled, and then once the retry when is done, then it continues further down the stream. Then you can see we're flat mapping it into a timer. This just allows, a certain period of delay before the retry message gets published back up to the top. And when that retry message gets published back up to the top, that's when the original observable is resubscribed to. So now we've somewhat built what we kind of had on the last screen, but we're doing it just in the stream. There's no external factors that could potentially throw us off. So at the very least, this is a little bit safer than what we had before. So this is fine, and this is good for maybe if you're doing some sort of background work, something that's not necessarily super important for the user's experience. You can kind of try it's best effort. We're trying a couple times to try and reload. If you wanted to get fancy with something like this, though, you could then tie the retry when to some sort of UI event. So say we had a button click for a retry button, and that we wanted to pass that back into the stream in order to retry a request after it fails. Well, since the retry when operator just takes an observable stream back and resubscribes to the parent observable whenever something is emitted from it, we can actually just use something like a relay or a subject and return that from retry when. And we now have a control then that we can just publish right back to our stream, and it will automatically resubscribe to the source observable without all of that having to be recreated. So in this example here, you can see we've just got a pretty simple relay where we're just publishing back in the system current time. And so we're not doing anything too fancy there. But every time the button is clicked, it will publish back into retry when. Retry when will resubscribe to the source observable, and the stream keeps going. So another issue in networking is your API might have very specific response codes for specific errors, right? And the whole world of HTTP errors is complex. There are a lot of them obviously defined out there in your standards, but you might want to add different sort of handling for each different type of error. So Retrofit absolutely supports you working with errors. By default, and in the canonical example, this isn't shown, but you can actually use Retrofit's response object instead of actually getting the fully parsed JSON object representation of JSON in your response, and you can access this response object and get the response code. So here we have our events response that we fetched from our API, and we can then check the response code, and we can do whatever we want with the response code. So this is pretty good, but one thing that trips people up though is that the 400 to 500 level errors, your errors, or your error response codes rather, are now being delivered in your successful part of your stream as opposed to your error part of your stream. So if you've built infrastructure around error handling that is on error, now they're kind of they're not quite in the same stream. So that's a little bit confusing. So you can actually still use the access the response T, but Retrofit kind of does something a little bit sneaky. Is every time there's a 400 or 500 error, it actually wraps the response object in a throwable and then emits that in the on error stream. So you actually just check if it's an HTTP exception. And if it's an HTTP exception, now you have access to your error, and you can switch on your response codes, and you can do whatever you need to do there. So that's pretty good. We've got some error handling. We can handle response codes pretty effectively in our application. But one thing you can do is take advantage of some of the power of RxJava, and you can use an operator like share and filter in order to handle specific options with completely different streams. So if you see the example here, where we've got the same observable where we're fetching our upcoming events, and we've got our response object coming in. But then we go to share it, and this creates a multicast point from there. So you can have multiple other streams coming out of this one point. So none of the work before the share will be repeated. So we're only making our network request once. But we can then split that stream several times to add different handling, different subscriptions, anything that we really want to do. So you can see here we have some examples where we have a stream now that is only handling the successful responses, and we have a stream here that is only handling the 403 responses, and a stream here that's only handling the 304. And so you can have all of these separate subscriptions, and you can separate your concerns so you don't have one subscriber that is handling this big massive switch. You now kind of have everything broken out into separate streams, and this offers a great deal of flexibility. So my designer wants a loading indicator. Not just your designer. I want you to have a loading indicator in your app too, because nothing is more frustrating as a user when you're lacking confidence in what's actually occurring in the application that you're using. So please show a loading indicator. And if you haven't tried it out yet, the content loading progress bar that's included in the design support library is a really useful tool for showing a progress bar during network requests, because it automatically ensures that you show your loading indicator for at least a certain period of time that it's humanly perceptible, so you don't see flashes of things showing on your screen, which can also create a lack of confidence for your users because they're not quite sure what just happened there. So let's take a look at how showing a loading indicator can be done in RxJava. So the goal is we want to show some sort of loading state. So we're back to our very basic subscription here, a very basic observable stream. And we're going to take a look at one approach that you might take to kind of hook in and make some loading states. So the first thing you might see is someone try and take advantage of do unsubscribe and do unsubscribe in order to hook into the life cycle of an observable and show a loading indicator at the start and then hide a loading indicator at the bottom. And at its surface, this is right. I mean, this will actually work and you'll show your loading indicator, but it's not taking into consideration what we've kind of done here, which is we've directly tied our user interface into like our data loading stream. And so we've not done a very good job of separating our concerns of our application. We now have kind of this data loading background work type aspect being tied to our UI. And this is always a dangerous thing in Android too, because this subscription is now going to leak references to views if it's not cleaned up properly, if the resources aren't cleaned up properly at the end or during the course of the stream when the activity is going to go through a configuration change or what it is. If you were to restructure this observable stream in a way too, where it becomes an actual stream where it doesn't complete anymore, do unsubscribe will get called, but do unsubscribe will never get called because the stream will continue emitting until it either receives an error event or a completion event. So now our loading indicator will never go away if we restructure this stream at all. So there's some other things that are troublesome here too. Like you have to be careful with your observe on with the thread that you're subscribing on, your scheduling concerns for showing and hiding because you don't want to modify the UI from a background thread. So this isn't probably a maintainable solution to that problem. So what are some things that we can do? The number one thing that I think you can do is start by splitting your stream. Separate your concerns. Break them out from each other. And what I mean by that is setting up two separate streams. One stream is responsible for loading your data, and the other stream is responsible for your loading state. So you can see here that we've created this enumeration that we're calling request state. We have a relay. You could also use a subject that is tracking the request state through the various states of the request. And now our observable stream, instead of calling directly into our user interface, is calling into a relay. You can think of relays as bridges. They're bridging the gap between an imperative style programming and a functional style of programming. So once we have this stuff in place, we have our loading being called, our error state being called, our completion state being called, we now have a separate stream that we can operate with in order to show our loading state. So now, in our user, say it's in our presenter or wherever it is, somewhere else in our user interface, we can now subscribe to just the request state, and we're not concerning ourselves with the actual data of the request or errors or anything like that, the specific error. But we're subscribing directly to it, and we can now show and hide our loading indicators and our error views without any risk, really, of embedding the view dependency into the stream. And we can very easily add, subscription management to this subscription as well. In a way that you can continue to let your request continue completion in the background, and then your UI can resubscribe to the request state later, and kind of resume that request. You could see how this might work in a more MVP style type model, where your presenter is subscribed to the request state and then calling the respective update methods on your view. So. If we wanted, we could then extend the stream splitting to also include our response and error messages so that everything is in separate streams. We've now got 3 separate streams going. We have our request state, we have our response, and we have our errors. And then I've actually thrown in a trigger stream here. So this is how you would refactor that stream to make it a flowing stream as opposed to one that's like a single where it's, completes. It has a success or an error. We now have a stream here. So we have some sort of trigger. That trigger is going to start cascading events through the stream. And that's where we have our do on next to start our loading state. We have our flat map to get our observable to talk to our API. We then have our observe on to deliver that result back on the main thread. We then, in our do on error, we're now publishing that error up to the relay. And we're then finally subscribing our response relay so that it gets the actual data that's going to our response. So now we have 3 different streams, all these things that are in flight. And this might seem like it's a bit too much, but when you start actually getting to your UI layer and you look at how you can then structure your subscriptions, because this is where it's actually being built into your application, you can start seeing how how much more straightforward this is than having one large subscriber or trying to work things into the subscriber methods, various callbacks. We're getting away from that now. We now have explicit states that we can subscribe to. So we have our request state where we're updating our loading view. We have, say we wanted to have a notification being shown about the loading state of this request at the same time that we're showing a user interface part of it. Well, since it's a relay and it's a multicast point by itself, we can very easily subscribe another thing here that's going to update a loading notification in the status bar in addition to the loading view that's being displayed on screen. And then we can obviously, we're subscribing to our response to show the actual events once they come back, or our errors where we can extract and show the error from whatever that error, that throwable was. So this is kind of how you can do all that. If this seems like it's a bit much and you don't need all of these streams, but you still want, something that updates regularly, what you can kind of do is more of like a UI model approach where you are going to, I call it a view model here. It's not a traditional view model. I understand that. It's a UI model for your data. But what you can do is you can split into all these streams like we just went over. And we can create a class like this, which is what we're calling a request view model. It's a UI model for the current state of the request as it's going through its in-flight. And using the nifty observable combine latest here, what we can actually do is at each point when each one of those relays updates, we're now combining them back into a singular object that we can then handle in our subscription. So, each time the request state updates, we'll have, either the response, whether it's there or not. We're using the optional here in order to indicate whether or not the response is there yet or the error is there yet. But we're also having full access to the request state, so we know when it moves from idle to loading to completed or idle to loading to error. And so by combining them all back together, we have now one subscription in our UI, but we have aspects to all these, or we have access to all the various aspects of the request that we're trying to track. So it becomes more straightforward to reason about. So, and this is a Kotlin example now. So if you wanted to take that previous example and start maybe moving things into a Kotlin world, Kotlin has a feature called sealed classes. And the best way to describe a sealed class is that it's relatively similar to a marker interface combined with an enum. So think about how you might use a marker interface in Java to indicate that this object is of a certain type, and then you can then kind of switch on the various types that might implement that. Well, Kotlin kind of takes that to the next level by making a sealed class restricted to only the types that are defined as part of the sealed class. So you don't have to worry about other types being created of the same type, and that allows you to safely, since they're enumerated, it allows you to safely iterate over the types in case statements. So you can see here where we have a very similar setup to what we were doing in the last, but it's in Kotlin this time. So we have our observable from callable where we're getting our events, and that's going to start a stream. We're then using the start with command to start with the request state loading, et cetera. And so what you're getting to is a stream, a singular stream, that represents the full state of the request. And at each step, in your subscriber, you can safely switch on the request state by using a when statement in Kotlin. And so you can then, when your request is idle, you clear your view. When it's loading, you show loading. When it's completed, you show your data. And when it is an error, you can show your error. And the nice part about using Kotlin for something like this is that since sealed classes can also have data classes, it's not just an enumeration, a static enumeration that doesn't have any contextual data that is being returned in your subscriber here. But when you actually receive the completed event, you'll notice that it's smart cast automatically to the complete object. And so we can access the response body right there without having to do any fancy casting or anything. So it's very powerful and it's very cool. I'm excited to see, as the Kotlin ecosystem gets more advanced and developed, how patterns like this might be used by application developers. So the last issue that many junior developers struggle with is the configuration changes issue, which is the number one bane of every Android developer's experience. It is the singular reason why we have all of these complex infrastructural elements in place in order to handle what happens when my network request is in flight and I have to move to a new activity for my user, all right? And so, as you're probably all aware, or hopefully aware, RxJava subscriptions by default last beyond the activity lifecycle the very same way that an async task would go beyond the activity lifecycle. So it's going to continue executing unless you do something to manage it. So subscription management now becomes a very important topic and a very important aspect of your application. So let's look at some subscription management styles. So out of the box, RxJava provides us with the disposable. If you're using RxJava 2, good time to upgrade. And it's formally the subscription object if you're still in an RxJava 1 world. And that holds a reference to the stream, or the subscription to the stream, so that we can dispose of that work whenever we choose. So at any time, we can call that disposable dispose message, a function, and RxJava will walk its way back up the chain, cancel any work that was pending, and it will prevent any new data from being emitted, and it will kind of end. So the question, of course, then becomes, when do we call this disposable dispose? And when in my life cycle should I do this? And depending on the type of call you're making, it depends. And that's the answer with everything, right? It always depends. So sometimes you might want to simply just cancel the request, in an appropriate lifecycle message and then restart things when you get back. And you're going to recreate your observable stream, and that's perfectly fine. And I think of that example as it's perfectly fine to use async task when you're loading data from a database because you're not doing anything that's long running. It has a relatively short execution time, and it's going to be done. So even if it's going to leak, it's not going to leak long. Everything's going to be okay. But that's not necessarily true in a network request. So, what are some strategies then we can employ when we're talking to the network? So here's an example of basic disposable usage that is just going to recreate our stream. So at some point in our activity here, we're subscribing to this observable, and at some point, or not at some point, in our onStop method of our activity, we're calling disposable dispose. This will cancel all that work. This will cancel that subscription, and we're not going to be recreating. We're going to have to recreate that stream in the case of a configuration change, and we're going to have to resubscribe to it later. So this is fine. It's maybe a little tedious, but we can keep track of all the disposables for all the subscriptions in our activity, and you can clear them all out in the appropriate lifecycle method, and this works. But we find that we often have many subscriptions that we need to manage, and so that's where composite disposable comes in. Now, composite disposable is a collection, essentially, of disposables. So you can continue during the course of your application or when you're setting up your user interfaces subscriptions to various observable streams. You can then add all of those disposables to a singular collection, and then in your appropriate lifecycle method, you can clear those subscriptions out from the disposable container, and you're all set. So I find this to be very convenient and very helpful. And when we're building our application, we often find ourselves building UI components that are kind of dependent on each other. So an example being you might have a list of elements that are being displayed, and then you might have some sort of filters controller that then modifies in an observable stream, modifies the events that are currently being displayed based on the filters that are being set. And then it creates this kind of circular loop where it's updating the data here, updating the data there, filtering the data here, updating the data there. And we want those subscriptions to end when the user's navigating away from the activity, so the data is not updating continuously in the background. And so we'll have the subscription to the filters that will be added to the disposable, as well as the UI's subscription to the button click to open the filters, and all the way down the cascading chain. If you've kind of seen examples of how to use RxJava in forms, you can imagine how this all kind of works together. So having one singular point where you can clear out all of your subscriptions is really nice, and it's really helpful. But say you're kind of lazy and you don't like keeping track of all of these things yourself. There's a very nifty tool out there called RxLifecycle. Now, RxLifecycle is not a golden hammer because there are some caveats with its usage. But in the 95% case, it's a very effective tool for letting you manage your subscriptions automatically, kind of with a wave of the magic hand, so to speak. It will take care of all of that for you. The way that RxLifecycle works is RxLifecycle takes advantage of an operator called take until. And take until is an operator that says, keep this subscription active for this given observable stream until this other observable stream emits. So now in Rx lifecycle, kind of behind the scenes, there's a separate observable stream that is each activity lifecycle callback for your activity or fragment or whatever it is. And when you call bind to lifecycle, based on whatever your current lifecycle is, so say you're calling it in onStart, it will determine that the corresponding one is onStop, and it will create a subscription that is taking until onStop gets called, and then it will automatically unsubscribe you, and so you don't have to deal with worrying about those updates anymore. If you've read a recent blog post by Dan Liu, the guy who wrote this library at Trello, he cautioned against its usage, and I'm going to caution you the same way that he did as well. This is great when you know exactly when your subscriptions are being created. Where this breaks down is if you have an observable that lives beyond the life cycle of your activity, and you can subscribe to it in either on create or on resume or whatever, and then the life cycle of your subscriber becomes vastly different because you're not sure when in your activity's life cycle the data is being received in your subscriber. So in the case where you're pretty much always subscribing in onStart and unsubscribing in onStop, this is a perfect solution and it's very convenient. So it's definitely something worth checking out. But like I said, be aware for the subtleties because there are implications to its usage. A nifty trick, all these examples that we've gone over up until this point don't do anything to continue the work that that observable is doing throughout the configuration change event. It's all of it's canceling the subscription, and that observable is being disposed, and we have to recreate it in the next. So here's an example of one way that you can continue an observable from one instance of an activity to the next one in the case of an orientation change event. I'll apologize in advance for the formatting here because it got a little messed up. But what we are doing is we are riding on the activity's non-configuration instance. And this isn't a very well documented thing that's available to use, but it is available and it's safe to use in all the frameworks despite what that deprecated message might say, which I think got removed. This method was deprecated for a while and now it's back. But what you can do is you can actually pass an object from one activity instance to another instance. And there's no restrictions at all on what that object can be. And so it can be say you have a very heavy observable stream that's performing a lot of work, you can keep that observable from stream to stream. Now, there's a little bit of setup that you have to do to use this, but what you can do is, say here we're creating an observable that is doing a lot of work. And in this case, it's a poor example, so we're just subscribing to a bunch of relays, but say it was a lot of work. We're going to use the cache operator in RxJava in order to essentially save the results of that observable. It's going to completely replay all of the onNext events and then either the onCompleted or onError event that was received up to that point in the cache operator. We're then going to save that request into a field. So we now have an observable request as a field in our activity, so we can access that cached observable whenever we want. Then, at some point in the future, when the activity goes through its configuration change, we're going to, we're going to take care of our subscription first in onStop. We're going to dispose of the initial subscription. But remember, we're only subscribing to the cached observable, not the initial one. So the observable itself will continue executing, but our subscription to it will have gone away. Once we get to the next activities on create, up at the very top there, you'll see that we're calling get last non-configuration instance. And what this will actually do is behind the scenes, it will actually call to the previous activity and say, hey, give me this field. And you can see we have it implemented here, and we have the cached observable being returned in the onRetain non-configuration instance. So now we have that same exact observable that we created in the last activity, and we're able to immediately resubscribe to it again. So you can see here in our onStart method, we're checking to see if we have a request already, and we don't have a subscription for it. Then we're going to go ahead and resubscribe to it. So there we go. Now we've continued an observable stream from one activity to the next activity. And you can actually use this onRetain non-configuration instance for any object, like I said. One thing that we use it for in our application that you might find useful is for preserving a Dagger component across activity instances. So you might have a Dagger component that has a collection of other observables that you want to preserve across this orientation change, and you can then re-inject those into your next activity. So you can actually you can improve that previous example a little bit by combining it with Rx lifecycle. Of course, you want to be a little careful. Again, we're making sure we always subscribe in on start and we always unsubscribe in on stop because that's what we want to make. We want to make sure that we're properly managing our subscription lifecycle when using Rx lifecycle. But you can improve upon that example like that. And if you want to continue improving on that example, at least in my opinion, and you're integrating it into, say, some form of MVP-like architecture, and you have a presenter, one thing that Rx Lifecycle allows you to do is it allows you to create your own life cycles. So as I mentioned, the activity and fragment already have their own built-in life cycles in Rx Lifecycle so that it can publish the activities on created, on start, on resume, on pause, on stop. We can actually create our own for our own presenter. So in my presenter, I use the started and stopped methods, but if you want to do bind and unbind, like totally up to you, you can define your own. But you can very easily use the something like this behavior relay here, and then the lifecycle transformer, which is part of the Rx lifecycle library, to create your own mapping from events, so started to stopped and stopped to started. And now, when you are inside your presenter, you can do things like subscribe to this observable stream, but unsubscribe from that observable stream when my presenter is unbound from its view. And so then you can think about all of the things that we just talked about, where you could have a presenter that survives through orientation changes, through the non-configuration instance, but only resubscribes to its observables once it's attached to its view. You now have a pretty simple application framework in place where you know that you can keep network requests going throughout your configuration changes and resubscribing to the data later. So that's pretty much all I have for you guys. Hopefully that was informative. If anyone has any questions, feel free to toss them up there, and I'll throw my information up here. Jacob.
So in that example where you were retaining the non-configuration instance for a observable, that would only work if the request is actually completed, right? There's no way to like persist a in-progress network request across activity rotation, is there? That you're aware of? Because I thought about that, but I couldn't figure it out.
So that is the answer to your question. That actually, since it's an observable stream and we're not unsubscribing from it because we're using that cache operator, it will not cancel the network request as it's in flight and will continue to load in the background and then eventually deliver its results, whether or not there's a subscriber there to handle it.
So adding the cache operator makes it so it doesn't actually cancel the request even though the subscriber has unsubscribed?
Yes.
Nice.
Yes. So then when you get to your next activity and you go back to get that observable and you resubscribe to it, if it's already completed, the result will be delivered immediately. If it hasn't completed, it will continue to load and do that. Now, if you combine that with what I just talked about with the loading state approach, it will actually already, with the methods of like splitting your streams in order to have separate loading states, you'll subscribe and immediately get the loading event as opposed to going through idle, then loading, because it'll already be in flight and it'll already be reflective of what that stream is currently doing. Thank you very much, everyone, for coming out. I will be posting the slides on my Twitter, so if you want to catch them later, that sort of thing, or talk with me online, whatever it is, I'll be wandering around and that sort of thing. So thank you very much all for your time. Thanks for coming out.